how to prepare a data format. Firstly, gather data. The data preparation begins with finding the right data. This can come from an existing data catalog or can be added ad hoc. Secondly, discover and access data. After collecting the data, it is important to discover each data set. This step is about getting to know the data and understanding what has to be done before the data becomes useful in a particular context. Third, cleanse and validate data. Cleaning up the data is traditionally the most time-consuming part of the data preparation process. Important tasks here include removing extraneous data and outliers, filling in missing values, conforming data to a standardized pattern, and masking private or sensitive data entries. Fourth, transform and enrich data. Transforming data is the process of updating the format of value entries in order to reach a well-defined outcome, or to make the data more easily understood by a wider audience. While enriching data refers to adding and connecting data with other related information to provide bigger insight. Lastly, store data. Once prepared, the data can be stored or channeled into a third-party application, such as a business intelligence tool. How data being divided? Data being divided by packet segmentation. Packet segmentation is the process of dividing a data packet into smaller units for transmission over the network. It happens at layer 4 of the OSI model, which is the transport layer. Protocols that perform packet segmentation at the source usually include a mechanism at the destination to reverse the process and reassemble the original packets from individual segments. In a communication system based on a layered OSI model, it may be responsible for splitting one MPDU into multiple physical layer service data units. Header for each layer. At each layer, a packet has two parts. Firstly, header. Header contains protocol information relevant to that layer. Secondly, body. Body contains the data for that layer, which often consists of a whole packet from the next layer in the stack. The packet contains all of the information passed from the higher layer. How header being added to each data? The transport layer receives the data stream from the upper layers. It breaks the received data stream into smaller pieces. This process is known as segmentation. After segmentation, it creates a header for each data piece and attaches that header to the data piece. What is network segmentation? Network segmentation is a process where a network is divided into several segments or subnets, each working as its own little network. Why is it important? It is important to control the flow of traffic between subnets. Next, it will allowing or disallowing traffic based on a variety of factors. Lastly, it can even block the entire flow of traffic if necessary. What is frames? Frames is a digital data transmission unit in computer networking and telecommunication. In packet switch system, a frame is a simple container for a single network packet. The PDU of the data link layer is called frames. The packets received from the network layer further processed to form the frames. Frames also help to determine how data receivers interpret a stream of data from a source. In general, the frame is a formatting resource for data that needs to be split up into recognizable pieces in order to be interpreted by a receiver. The sequence impedance network is defined as a balanced equivalent network for the balanced power system under an imagined working condition so that only single sequence component of voltage and current is present in the system. Every power system has three sequence network, which is positive, negative, and zero sequence network, and these networks carrying three sequence current. The positive sequence network is the same as that of the sequence reactance or impedance network. The negative sequence network is similar to the positive sequence network, but the only difference is that a negative sequence network is of opposite sign to that of the positive sequence impedance. Lastly, the zero sequence network will be internally free of the internal fault point and the flow of current being caused by the voltage at the fault point. Next is address route. Address route is a process that sends packets from a host to another host. It helps to examine the destination of IP address of a packet and determine next hook address, then forward it. Next, MAC address and IP address. MAC address is a unique identifier that is assigned to an NIC, which is Network Interface Card, and IP address is a numerical label that is connected to a computer network that uses the Internet Protocol for communication. MAC address. MAC address provides a secure way to find senders or receivers in the network. It helps prevent unwanted network access. Next, MAC address is also used in Wi-Fi networks at the airport for a specific device in order to identify it. It also ensures the computer device physical location. It helps us identify a given device on the available network uniquely. MAC address containing 6 outlets. IP address are the identifier that allows information to be sent between devices on a network. There's 2 main functions of IP address. Firstly, as network interface identification, and secondly, as a location addressing. They contain location information and make devices accessible for communication. Internet Protocol version IPv4 defines an IP address as a 32-bit number, and a new version of IPv6 using 128 bits for the IP address. Packet forwarding. Packet forwarding is the process of a networking component accepting a packet and transmitting it to its destination. For example, a router receives packets from hosts on one attached network and forwards them to hosts on another attached network or to another router for further forwarding. Error control related. Error control in the data link layer is a process of detecting and retransmitting the data which has been lost or corrupted during the transmission of data. Any reliable system must have a mechanism for detecting and correcting such errors. Error detection and correction occur at both the transport layer and the data link layer. There's 2 types of error. Firstly, single bit error. Secondly, burst error. Handshake protocol. Handshake protocol involves between a web client and a web server. It is to establish trust and negotiate secret key to encrypt and decrypt the conversation. It is also to ensure a safe transaction. TCP/IP stands for Transmission Control Protocol or Internet Protocol and is a suite of communication protocols used to interconnect network devices on the Internet. TCP/IP protocol suite functions as an abstraction layer between Internet applications and the routing and switching fabric. It will specify how data is exchanged over the Internet by providing end-to-end communications. TCP/IP requires little central management and is designed to make networks reliable with the ability to recover automatically from the failure of any device on the network. TCP/IP suite of protocols is classified as stateless, which means each client request is considered new because it is unrelated to previous requests. Being stateless frees up network paths so they can be used continuously. What is UDP? UDP stands for User Datagram Protocol. It is a communications protocol that is primarily used to establish low latency and loss tolerating connections between applications on the Internet. UDP provides a mechanism to detect corrupt data in packets, but it does not attempt to solve other problems that arise with packets, such as loss or out of order packets. That's why UDP is sometimes known as the Unreliable Data Protocol. When sending packets using UDP over IP, the data portion of each IP packet is formatted as a UDP segment. Each UDP segment contains an 8-byte header and variable length data. Network routing is the process of selecting a path across one or more networks. The principles of routing can apply to any type of network, from telephone networks to public transportation. In packet switching networks, such as the Internet, routing selects the path for Internet protocol packets to travel from their origin to their destination. Routers refer to internal routing tables to make decisions about how to route packets along network paths. A routing table records the path that packets should take to reach every destination that the router is responsible for. Dynamic routing tables update automatically. Dynamic routers use various routing protocols to determine the shortest and fastest path. A subnet is a network inside a network. Subnets make networks more efficient. Through subnetting, network traffic can travel a shorter distance without passing through unnecessary routers to reach its destination. A subnet mask is like an IP address, but for only internal usage within a network. Subnetting narrows down the IP address to usage within a range of devices. Subnet addressing allows an autonomous system made up of multiple networks to share the same internet address. The subnetwork capability of TCP/IP also makes it possible to divide a single network into multiple logical networks. A standard Internet Protocol address field has two parts, which is a network address and a local address. To make subnets possible, the local address part of an Internet address is divided into a subnet number and a host number. The subnet is identified so that the local autonomous system can route message reliably. Inside a computer, there are electric cables and circuits that convey all of the information. If we had a single line carrying electricity, the signal may be on or off, true or false, 1 or 0. The on and off state of a single wire is referred to as a bit, which is the smallest unit of data in computing. The user enters data or input into the central processing unit of a computer. The moduler, sometimes known as a modem, electrically encodes information into a binary language consisting of 1 and 0, which may then be sent through cables or frequency waves. The data is sent and enters the host central processor unit, where the binary code is translated by the demodulator, another modem, and broadcast onto the host monitor. Twisted pair, coax, and fiber optic cables are the three main types of data cables used to carry data. These three types of cables are utilized in various situations. Twisted pair cables are mostly used in computer networking and telephone communication. A topology is an arrangement of nodes in a computer network that allows communication between all nodes. There are two types of topology, which is physical topology and logical topology. The location of various nodes is referred to as physical topology. Meanwhile, logical topology describes how data will move from one node to another.
Hello guys! We are going to learn about the OSI model, which is one of the learning topics in computer network subject. The model is for understanding and developing network computer-to-computer communications. It was developed by International Organization for Standardization (ISO) in the 1984. Want to know more? Let's get into our lesson. Based on the question given, we want to send a message which is, "Hello, my name is ZULAIKHA. I love UPNM. I will be graduating in 2022 with a CGPA of 4.0. I will work hard to make sure that I can achieve something that could give a positive impact on my life while enrolling in a degree study at UPNM. Basically, we want to explain how the message will be sent from node A, which is located at Upnm, to node B, located at UMS, University Malaysia Sabah, using the 7 layers of OSI model. Therefore, we need to understand first what is the meaning of the OSI model and the 7 layers. OSI stands for Open Systems Interconnection Model. A simple way to understand, it tells us how data travel in a network. There are 7 layers within the model, and the depiction of the layers is used to help users identify what is happening within the networking system. The purpose of this model is to enable functionality and the interoperability between different vendors and connectors. Although 2 or 3 OSI levels may be merged into one, much of the functionality in the OSI model occurs in all communication systems. In order to accomplish a successful communication between computers, there are 7 distinct layers which are interconnected and which work closely to make the communication happen. The layers of the OSI model are normally explained from the top layer down. Application, presentation, session, transport, network, data link, and physical. We can memorize each layer by practicing please do not throw away source pizza. Please for physical, do for data link, not for network, throw for transport, away for application, source for session, and pizza for presentation. These layers are provided by a combination of network card drivers, operating systems, applications, and networking hardware that allow signals to be sent over Ethernet, fiber optic, Wi-Fi, or other wireless protocols. The top 3 levels of these 7 are application, presentation, and session, which deal with the application on your computer. The hardware devices are dealt with at the lowest 3 levels, which are network, data link, and physical. The transport layer is in charge of the data transmission from beginning to end.
Now, let me explain first how the OSI model transfer data from one computer to another. There must be a sender and a receiver to send and receive data. On both sides, we have double 7 layers for each sender and receiver. From the sender side, the data will travel from the application layer toward the physical layer. Once the data reach the physical layer on the sender side, the data will be sent to the physical layer on the receiver side. This physical layer is going to forward the data to the upper layer of OSI model, that is the application layer. Once data reach the application layer on the receiver side, the user is able to read the message. This entire process is called an encapsulation. When the data travels from receiver side to the sender side, it is called decapsulation. The process is still the same as the encapsulation but vice versa. Data flow example. First, we need to find out the size of each segment. Based on the message, we find that size of the packet is 1,816 packets. So, the segment will be divided into 32 bits. There will be 56.75 segments through all the layers. Using the 7 layers method, data travels from the sending computer down through all the layers to the physical layer where the data is put onto the network cabling and then sent to the physical layer of the receiving computer where the process reverses and the data travels up through the layers to the application layer of the receiving computer. Layer 7. Application layer. This is the only layer where users can directly interact with the software application. The application layer provides network services to the end user. These services are protocols that work with the data the client is using. There are many application layer protocols that enable functions such as DNS, FTP, SMTP, and MIME. We can send the message by using the protocols. SMTP protocol is used to send the message via network application. Other examples of applications that use this layer are Google Chrome, Outlook, and Skype. The application layer will identify the sender and intent receiver. Is there a message application available? Then, the message has to pass to the presentation layer via this application layer. On the receiver side, this layer will identify sender and intent receiver. Then, it found the message through network application use. The presentation layer or layer 6 performs three basic functions, which is transmission, compression, and also encryption and decryption on the message. Application will transmit the encrypted message to the presentation layer that will need to be decrypted and processed. On the sender side, presentation layer receives message from application layer and will encode the data with X coding key, use ASYIQIN characters to mission code. Encryption enhances the security of sensitivity data at the sender side. On the receiver side, message is decrypted with X decoding key, use ASYIQIN characters as protocols is used in this layer. After the presentation layer process the message from one format to another, the information is then passed to the session layer or the application layer depending on whether the data is transmitting or receiving. The session layer or layer 5 performs initialize and terminates the communications according to X protocol on the sender side. This layer is responsible for establishing, managing, authentication, and reconnections if a network interruption should occur. After the session is established, the data is then passed to or from the transport layer. On the receiver side, message that is initiate and terminate the session according to X protocol. The transport layer or layer 4 is responsible for connection-oriented transmission and connectionless transmission. On the sender side, this layer makes sure how much data to send, how fast, where it goes, and these sorts of things. Of the most widely known protocols for Internet applications, these services may be provided by Transmission Control Protocol or TCP and User Datagram Protocol or UDP. Other protocols may provide additional capabilities including error recovery, data flow, and retransmission. On the receiver side, this layer will make sure all data has arrived intact. Once the transport layer has completed its function, the data is then passed to or from the network layer. It will then be segmented in the transportation layer. The main functions of network layer are routing and logical addressing. The network layer protocols determine which routes from node A to node B in order to send message on a correct route. This layer also defines an addressing scheme to uniquely identify devices. It keeps track on how many hops are used. Using the command prompt, there are 8 hops that can be recognized to send the message from node A to node B. After the message arrives at this layer, each frame of data is examined to conclude if the data has reached its ultimate target. The layer sends data to the correct destination on outgoing transmission and receives incoming transmission as well. The IP portion of TCP or IP is the commonly known network layer for the Internet. This layer also manages the mapping between logical addresses and physical addresses for IP addresses. IP address at node A, which is located at University Pertahanan Nasional Malaysia. IP address at node B, which is located at University Malaysia Sabah. Routers are crucial components as they route the message to where it needs to go between different networks. The data is then passed to the next required layer, which is the data link layer. The data link layer or layer 2 is considered the most complex layer. This layer is divided into sub-layers called Media Access Control or MAC and Logical Link Control or LSC. The MAC address layer is responsible for flow control and multiplexing devices transmissions over the network. LLC provides error control and flows control over physical medium and identifiers line protocols. The layer setups link across the physical network. When this layer receives data from the physical layer, it checks for transmission errors and then packages the bits into data frames according to as standard on the sender side. It ensures that any data transfer is error-free between nodes over the physical layer. Once it reaches the receiver, The initial connection is already set up and decoded data in the frame according to X standard. The last one is physical layer or layer 1. This physical layer is the electrical or physical layer of the model. This layer includes physical resources like network cables, power plugs, wireless radio frequency, connectors, receivers, or electric voltage. It takes care of the transmission of raw bit streams. When troubleshooting problems, this is typically the first place to start for sender to check. Is the device plugged in? Is the wireless card working? At this layer, the model transmits the digital data bits from the source or sends the device's physical layer over network communications media, which can be electrical, mechanical, or radio to the receiving or destination device's physical layer. Data will convert to 0 and 1 and then sent through a physical medium. Once the electrical signal is sent over the network cable, your friend gets the message through the physical medium. The data flows through the same layers, but in the opposite way. The physical layer will convert 0 and 1 to frames that will pass to the data links layer that will reassemble the frames into packets for the next layer. And that's it. The message will reach at UMS only for seconds, but actually it has been through the 7 layers of OSI model. The OSI model is a guide for developers and vendors to smooth the progress of developing communication product and software programs that will work in cooperation with a commonly established model. Once we understand the model, we can understand which protocols and devices will be compatible with one another. Thank you.